Introducing the concept of momentum. So, momentum is a tricky one. In Newton's time, he described momentum as the quantity of motion. Problem is, modern way of thinking about the words used there would be that quantity of motion would probably be thought of as a velocity or a speed rather than thinking of it as a momentum. Um, kind of get the idea across. Let's get the equation for momentum out there first. Momentum is a vector. We use a lowercase p to represent it. And momentum is equal to m times the velocity vector. So p as a vector is equal to mass times velocity as a vector. So that means momentum points in the same direction as your velocity. All right, so you see it depends on two things. Why quantity of motion? Ooh, I've misspelled quantity up here. Quantity is because of the mass. So think about it this way. If somebody said, hey, I'm going to toss this ping pong ball to you, you'd probably be like, okay. If somebody said, hey, I'm going to toss this bowling ball to you, you'd probably be like, hey, wait. Why? Well, because ping pong ball, tiny mass, ooh, scary, sure, shoot that thing at me at 50 miles an hour. Might sting a little bit, I'll be fine. Shoot a bowling ball? Oh no, heck no, you are not shooting that bowling ball at me at 50 miles an hour. There's clearly a difference based on how much matter is present in those cases. Yes, kinetic energy has something to do with it, but momentum is also something that increases as the velocity increases. So, that is a thing. I think I sat down and did a calculation once that a nuclear powered aircraft carrier going flat out has about the same amount of momentum as like a SR 71 fully fueled going at Mach 3. You get really interesting things like that, where tremendous amounts of mass, but the speed isn't actually all that high. Like your car on the freeway goes faster than an aircraft carrier. Or like an SR 71, which is heavy, but it's just going so insanely fast compared to other things that it has a very large momentum. Okay, the most important thing to remember is that momentum is a vector quantity. So two things that are headed towards each other have positive and negative momentums. One will be positive, one will be negative. That becomes very important as we get later on in the chapter and start talking about the conservation of momentum. So remember that direction matters whenever you're talking about momentum. Okay, of course, if you have no speed, you have no momentum. If something has no mass, well, it's complicated. Most things that have no mass would have no momentum. But it is possible to have no mass and have momentum. You'll learn about that as you learn about light in a much later chapter. All right. For now, we just wanted to introduce the concept, give it a definition, talk about some of those neat factors, and I'll remind everyone again. Depends on mass. Lots of mass going slow is scary. O is little mass going very fast. Momentum is a vector. And you must, absolutely must, always consider directions. All right, I'm actually going to close this with a bit of a story I've heard. It'll take a minute here. I heard that back during the Civil War, occasionally they would shoot cannonballs at each other on a very low trajectory so they'd hit the ground and then bounce and roll along the ground. Apparently this was done because soldiers had kind of the bad habit of seeing this cannonball rolling across the ground and going, oh, free cannonball, and sticking out their foot to stop it. Thing is, a cannonball has a lot of mass. It's not like a normal ball rolling along the ground. This apparently resulted in a fair number of broken feet and legs. So getting soldiers off the battlefield. People are very clever when it comes to hurting each other, is all I can say about that. All right, so let's stop it there. We'll talk about where some of this stuff comes from and what we can do with it coming up next.